Bismillahirrahmanirrahim. Assalamu alaikum students. This is your third lecture of physics. In this lecture, I'm going to discuss again waves, which is a topic of unit number 10 of simple harmonic motion and waves of 10th class. In this lecture, we will discuss wave as a carrier of energy, relation between velocity, frequency and wavelength, and ripple tank. Energy can be transferred from one place to another through waves, as we are going to see in the animation clearly that when we stretched a string and move it up and down, then a set of wave is going to be generated. As you can clearly see in the animation that by moving the string up and down, a set of wave is generated. What we have to do, or what actually is going to be happen there, is that when we move the string up and down, we basically transfer our muscular energy to the string, and as a result a set of waves are produced over there along the string. Actually, what happens when we start vibrating the string? When we start vibrating the string, the vibrating force from the hand disturbs the particle of the strings and set them in motion. As you can see that a particle with the orange color start moving up and down. It basically represents the disturbance of the particle. As these particles transfer their energy to the adjacent particle in the string, so this energy is transferred from one end to another end of the medium in the form of wave. As it is cleared from the above two animation that the amount of energy carried by the wave depends upon two factors. Number one, it depends upon the distance of the stretch string from its rest position. That is, the energy in the wave depends on the wave amplitude. Similarly, if we shake the string faster, we will give more energy per second to produce wave of higher frequency, means we can increase the number of waves, and the wave deliver more energy per second to the particles of the string as it moves forward. So this clears that wave energy depend upon two factors. Number one is the amplitude of the wave, and number two is the frequency of the wave. Water waves also transfer energy. As you can see in the animation that a water droplet drops into the pond of water and water waves will be produced on the surface of water and they travel outwards. Now if we place a cork at some distance from the following water droplet, then we will see that when these waves reach the cork, it will move the cork in up and down along with the motion of the water particles by getting the energy from the water waves. It means that water waves, like other waves, transfer energy from one place to another without transferring matter, that is water, means that water is a matter. Now we will discuss wave equation. The relation between velocity, frequency and wavelength of the wave is known as wave equation. Wave is basically a disturbance in a medium which travels from one place to another. Hence, it has a specific velocity. So, the velocity of the wave is defined as velocity is equals to distance divided by time, and it is symbolically represented by v is equals to d by t. As we discussed wave, so the time taken by the wave in moving from one point to another is equal to the time period of the wave, and it is represented by capital T. And the distance covered by the wave will be equal to one wavelength, which is represented by a Greek letter lambda. So the definition of the velocity of the wave is v is equals to lambda by t. But as we know that time period is a reciprocal of frequency, that is t is equals to 1 by f, so we can change the above equation as, or rewrite it as, V is equals to F lambda, which is our wave equation. And by using this wave equation, we are going to solve several numericals in our exercise. Now we will discuss ripple tank, which is the last topic of today's lecture. What actually is a ripple tank? Ripple tank is a device to produce water waves and to study their characteristic. As you can see in the figure, that a rectangular glass tray having a glass bottom and is placed nearly half meter above the surface of our table, and a screen is placed beneath the glass tray so that we can observe the wave patterns and wave motion on the screen. Waves can be produced on the surface of the water present in the tray by means of a vibrator, as you clearly see the vibrator, which is connected with the power supply. This vibrator is an oscillating electric motor fixed on a wooden plate over the tray. When we lower it to the surface of the water and when it starts to touch the surface of water and we set the vibrator on, the wooden plate starts to vibrate and start generating the water waves on the surface of the water. As the water waves start to generate on the surface of the water are the straight water waves. So we can see the water pattern on the screen. An electric bulb is hung above the tray to observe the image of the water waves on the paper or the screen placed beneath the tray. As we know that an electric bulb is hung above the tray to observe the image of the water waves on the paper or on the screen, and we can see it clearly that a series of bright and dark lines are appear on the screen. These bright and dark lines are known as crest and trough of the waves, which appears as a bright and dark lines, or it is known as bright or dark fringes. As we can see that the bright lines shows the crests, whereas the dark lines appear as a trough. Now at the end of this lecture, I am going to give you some questions for your own practice related to this lecture that derive a relationship between velocity, frequency and wavelength of a wave. Write a formula relating velocity of a wave to its time period and wavelength. And waves are the means of energy transfer without transfer of matter. Justify this statement with the help of a simple experiment. Those experiments are discussed in this lecture as well. Also, you are able to solve the numerical problems like 10.5, 10.6 and 10.7 by using the simple formula V is equals to F lambda or V is equals to lambda by T. You can also use the formula V is equals to D by T. You can also use the formula as T is equals to 1 by F. I hope you will enjoy this lecture. Inshallah, we will meet in the next lecture. Until then, Allah Hafiz.